feeling like you're trying to drink from a fire hose of data these days.
Oh, absolutely.
It's everywhere, isn't it? Just coming from all directions.
Yeah.
Ever wish you could just, cut through it all and understand the real story without needing a PhD?
That feeling, that sense of being overwhelmed, that's actually what's driven this whole fascinating evolution in how we handle data.
Right.
The methods have had to change dramatically just to keep up.
Well, if that sounds familiar to you listening, you're definitely in the right place. Today's deep dive is kind of your shortcut to understanding how data management has evolved. Think of it as the quick guide to the data world, hitting the highlights without getting totally bogged down.
Exactly. And, this isn't just theory. We're basing this on a whole stack of sources you provided, specifically looking at that journey from, say, traditional data warehouses, all the way to this newer idea, the data mesh.
Yeah, our mission here is really to pull out the essential bits from all that material, explain why these changes happened, and sort of pinpoint what you really need to know to get a handle on modern data management. It's about clarity, getting to the heart of it.
Yep.
And to guide us, we've got our expert right here.
Ready when you are. Let's dive in.
Okay, so let's start right at the beginning. The foundation, the data warehouse. What was the core idea there?
So the data warehouse, that was really the first big attempt to centralize data for analysis. The key insight was bringing together structured data, stuff that fits nicely into rows and columns, into tables.
Right, orderly data.
Orderly data, exactly. Into one single consistent place for business intelligence. Think of it like consolidating files from scattered cabinets into one really well-organized library. But importantly, only for specific kinds of books or documents.
Okay, a structured library. So what are the key parts of this library?
Typically, you'd see a kind of three-tier structure. First, there's like a staging area, an intake where data first lands. Then, the core is the analysis engine, often called an OLOP engine. That's what lets you do those complex BI queries. And finally, you've got the front-end tools, the reports that people actually use.
Gotcha.
And underpinning it all is the database system itself. That's critical. We've seen a big shift there over time towards columnar databases.
Right. Storing by column instead of row.
Exactly. And cloud options like Amazon Redshift, Google BigQuery. Storing by column makes analytical queries way faster because you only read the columns you actually need for that analysis.
Makes sense.
And of course, you needed and still need serious storage disk arrays, now SSDs, cloud storage, and significant processing power.
Okay, so you build this powerful, structured system for asking these specific analytical questions.
Yeah.
But how does the data actually get into it?
Right, that's where ETL comes in.
Yep.
Extract, transform, load. That's the classic engineering principle here.
Okay.
First, you extract the data, pull it out from all your different operational systems, sales, inventory, whatever.
Yeah.
Then, the crucial step, transform.
That sounds important.
Oh, it is. This is where you clean it up, make sure it's consistent, maybe change format so it fits the structure of the warehouse. Quality control, basically.
Okay.
And finally, you load that cleaned, prepared data into the warehouse.
In that transformation stage, that's really key for making sure everything, plays nicely together inside the warehouse.
Absolutely vital. It's all about ensuring that data quality and consistency, which ties into another key principle, Schema-on-Write.
Schema-on-Write. Okay, break that down.
So think back to our library analogy. Before you put any books on a shelf,
Yeah.
you have to decide what that shelf is for. Is it fiction, history, science? You define the structure, the schema, before you write the data in.
Label the shelves first.
Exactly. Label the shelves first. That way, when someone comes looking for, say, historical fiction, they know exactly where to go and what format the books or data will be in. It ensures consistency for querying.
That makes a lot of sense for keeping things orderly. And I remember the sources mentioning different ways to actually organize the data inside the warehouse, like specific models.
Right, that's data modeling. And two really common patterns are the star schema and the snowflake schema.
Star and snowflake, okay.
So a star schema is simpler. You have a central fact table that holds your core numbers, your metrics like sales figures, and around it you have dimension tables that give context, time, product, location. Looks like a star.
Got it. Central facts surrounding context.
Exactly. A snowflake schema is basically a more normalized version of that. Those dimension tables might be broken down further into more tables to reduce redundancy.
So like the points of the star have their own smaller points.
Kind of, yeah. The star schema is generally simpler and faster for many queries. The snowflake reduces data repetition, which can save space, but might make queries a bit more complex. So it's a trade-off, really. Simplicity versus storage efficiency.
Okay, so the data warehouse sounds, well, pretty great for what it was designed for. But the sources definitely pointed out some limitations. What were the main issues?
Yeah, you're right. It started to show its age, especially with newer data types. It really struggled with the explosion of unstructured data, text, images, video feeds, social media posts. It just wasn't built for that.
Because it needs that predefined structure.
Precisely. That schema-on-write approach, while good for consistency, also made it really inflexible. If your business needs change or you got new data sources,
Wow.
changing that schema and rewriting all those ETL jobs could be a massive, slow, expensive project. ETL itself often became a bottleneck.
Right, I remember that point.
Yeah.
Delaying insights.
Exactly. Data latency. The data in the warehouse might be hours or even days old. And scaling the old traditional warehouses, that could get really costly and complex, especially for truly massive data sets. Plus, because the data was often pre-aggregated or transformed, it wasn't always great for doing really deep exploratory analysis or machine learning on the original raw data. You'd already kind of cooked it.
Okay, so as data got bigger, faster, messier,
Hmm.
the warehouse started to creak.
Yeah.
And that's where the data lake comes in, is that right?
That's exactly the transition. The data lake emerged as a direct response to those warehouse limitations. It offered a much more flexible, adaptable approach.
Flexible how?
Well, imagine, at least in the early days, this vast repository, sometimes called a data swamp, and maybe we'll get into why,
Okay.
designed to store any kind of data. Structured, semi-structured, totally unstructured. Just pour it all in its original raw format.
So less about careful organization up front, more about just capturing everything. What kind of infrastructure lets you do that?
Scalability and cost-effectiveness became the name of the game. Data lakes lean heavily on cloud object storage. Think Amazon S3, Azure Blob Storage, Google Cloud Storage.
Right, the big cloud storage options.
Yeah, they offer massive scale relatively cheaply. And a really key architectural shift was the separation of storage and compute.
How's that different?
In many traditional warehouses, storage and processing power were tightly bundled. If you needed more storage, you often had to buy more compute, and vice versa. In data lakes, they're separate. You can scale up your storage independently of your processing power using engines like Apache Spark or Presto, now Trino.
Ah, so you only pay for the processing you actually use when you use it.
Pretty much. It allows for much better cost optimization and flexibility.
Okay, so you've got this giant scalable pool of raw data. How do you actually work with it? The engineering must be different from the warehouse ETL model.
Completely different mindset. Instead of ETL, you typically see ELT. Extract, load, transform.
Load before transform.
Exactly. You extract the raw data, you load it straight into the lake, and then you transform it only when you need to for a specific analysis or use case.
Okay, that sounds much more flexible.
It is. And instead of schema-on-write, you have schema-on-read.
Right, you mentioned that contrast.
Yeah, so you don't force a structure on the data when it arrives. You apply a schema or structure only when you're actually reading or querying the data.
So going back to the library idea, it's like throwing all the books into a giant room and only deciding how to categorize them when you need to find something specific.
That's a pretty good analogy, yeah. Or like a box of unsorted photos, you just dump them in. Only when you decide, I want to find all the beach photos, do you start sorting and applying that beach schema.
Gotcha.
Data ingestion also gets more varied. You can handle batch uploads, real-time streams, kind of hybrid approaches, all landing in the same lake. But, this is a big but,
Here comes the swamp part.
here comes the potential swamp. Because you have all this raw, potentially messy data, metadata management becomes absolutely crucial.
Metadata. Data about the data.
Exactly. You need data catalogs like the librarians for this messy room of books and really good metadata to help people find what's in there, understand it, and importantly, trust it.
So the lake gave us flexibility, but you use that term data swamp. What actually went wrong? Why did some lakes become swamps?
That's the flip side of flexibility, because there wasn't always that enforced structure or strong governance up front.
Yeah.
It was easy for data lakes to just become dumping grounds, messy, poorly documented, untrusted. It could be incredibly hard to find valuable data, let alone verify its quality or manage security and compliance effectively.
It's hard to get value out of it.
Very hard.
Yeah.
And querying raw, unstructured data directly could be slow and often required specialized skills, like data scientists who knew how to wrangle that raw stuff. So the initial promise of flexibility, if not managed well with governance and metadata, could easily lead to chaos. It's almost a cautionary tale, isn't it?
Yeah, it sounds like it. Flexibility is great, but too much without guardrails leads to a swamp.
Precisely.
Okay, so the data lake tackled the inflexibility of the warehouse, but introduced potential chaos around governance and quality. This feels like the perfect setup for the next step. The data lakehouse, trying to fix the lake.
You got it. The Data Lakehouse is essentially an attempt to bridge that gap, to get the best of both worlds, combining the good parts of the lake, flexibility, cost-effectiveness, handling diverse data with the strengths of the warehouse reliability, performance, governance.
Okay, best of both. How does it actually do that architecturally? What are the layers?
It basically builds smarter layers on top of that data lake foundation. You still have the cheap, scalable storage layer, often cloud object storage like S3 or ADLS.
Right, the lake itself.
The lake itself. But then, crucially, you add a sophisticated metadata and management layer on top. This layer is key. It brings structure when needed, enforces schemas, provides AC transaction support.
ACID, what's that?
Good question. ACID stands for Atomicity, Consistency, Isolation, Durability. It's a database concept ensuring that transactions are processed reliably. So either a whole transaction completes successfully or it doesn't happen at all. No partial updates, no corrupted data. It brings that database level reliability to the data lake.
Okay, so reliability on top of the flexible storage.
Exactly. This layer also enables things like indexing for faster queries and fine-grained access control. So it's bringing warehouse-like management features to the lake data. And then you still have your analytics and consumption layer on top where users connect with their tools. Importantly, storage and compute usually remain separate.
Right, keeping that scalability benefit.
Keeping that scalability and cost optimization, yeah.
So it's like we found that giant room of books from the data lake, but now we've added a really smart searchable catalog, maybe some clear aisles and rules about checking books out.
That's a great way to put it, yes. And that changes the engineering principles again.
How so?
Well, you get the ability to mix and match. You can still use Schema-on-Read for exploration on raw data, but you can also enforce schemas for structured tables, like in a warehouse, for BI reporting. You get those AC transactions we mentioned, adding that crucial reliability layer missing in vanilla data lakes. And they leverage powerful, optimized query engines. Spark, Prestotrino, are common, again, designed to run fast SQL queries directly on the data lake storage, often using special table formats.
And batch versus streaming.
It aims to handle both seamlessly on the same platform, a unified approach.
Okay, that sounds like a really significant improvement.
Yeah.
What are the big wins for a lake house compared to just a lake or just a warehouse?
Compared to a typical data lake, you're getting much better governance, much better data quality control, and usually much better query performance for structured queries.
Right. Less swampy.
Definitely less swampy. Compared to a traditional data warehouse, you retain that flexibility to handle all sorts of data types, structured, unstructured. You generally get cheaper storage costs thanks to the cloud object stores, and you can support a wider range of analytics, BI, SQL, but also machine learning directly on potentially less processed data. The goal is often striving for that single source of truth across diverse needs.
And what are some of the key technologies making this lakehouse thing happen? You mentioned table formats.
Yeah, the open source table formats are huge here. Things like Apache Iceberg, Delta Lake, and Apache Hudi. They are the magic layer that adds ACD, schema enforcement, time travel, and other management features directly onto the lake files.
Okay.
And then you have the big commercial platforms really pushing this vision. Databricks is a major player, Snowflake has lakehouse capabilities, and the cloud providers like AWS, Redshift Spectrum, Google, BigQuery, and Microsoft, Azure Synapse Analytics, all offer services in this space.
You mentioned metadata and quality are crucial again here. How does the lakehouse ensure those?
They are absolutely central to the lakehouse concept. You need that unified data catalog that understands these new table formats. You need robust schema enforcement and, importantly, schema evolution, allowing structures to change over time gracefully. Built-in data quality checks and strong governance frameworks for access control and compliance are fundamental. It's all about making that flexible data lake environment trustworthy and performant enough for critical workloads.
Okay, wow. So warehouse, then lakehouse, trying to combine them. But if the story doesn't end there, does it? The sources talked a lot about data mesh. This sounds different, like fundamentally different.
It really is. Data mesh is less an evolution of the previous architectures and more of a paradigm shift, a radical rethinking. It moves away from centralized control entirely towards a decentralized model where data ownership and responsibility are distributed out to the business domains that produce and understand the data best.
Okay, decentralized domain ownership. What does that actually look like? Give me an example.
Sure. So instead of one central data team managing all the data, the marketing team owns and is responsible for the marketing data. The sales team owns the sales data. The finance team owns the finance data.
Yeah.
The idea is that these domain teams have the deepest context and expertise about their specific data. They understand its nuances, its quality issues, how it should be used. So putting ownership with them should lead to better, more relevant, more trustworthy data.
Okay, that makes intuitive sense. And another term I saw was data as a product. What's that about?
This is a core principle. It means shifting the mindset. Domains shouldn't just hoard their data. They should treat their key data assets as products they offer to the rest of the organization, the internal consumers.
Products?
Yeah.
Like with features and support?
Kind of, yeah. These data products need to be discoverable, easy to find, understandable, well-documented, trustworthy, high quality, reliable, addressable, have stable APIs or access points, secure, and interoperable. The domain team takes pride in their data product and ensures it meets the needs of its consumers.
Okay, so domains own their data and treat it like a product.
Yeah.
But they can't just do this in a vacuum, right? That leads to another principle, self-serve infrastructure.
Exactly right. You can't just tell the marketing team, okay, build your own data warehouse. That won't work. The data mesh concept relies on having a central platform team that provides shared self-serve infrastructure and tools.
So common tools for everyone.
Common tools, common standards, common capabilities for storage, pipelines, monitoring, discovery, access control. This platform empowers the domain teams to build, deploy, and manage their own data products efficiently without reinventing the wheel or needing constant hand-holding from a central bottleneck team.
Okay, that makes sense. Empowering the domains. And the last big principle was federated governance.
Yeah.
How do you stop this decentralized system from just becoming like total chaos? Different domains doing completely different things.
That's the million-dollar question, and federated governance is the answer. It's about finding a balance. You need some global rules, some organization-wide standards and policies for security, for privacy, for interoperability, maybe for certain metadata fields.
Okay, some central guardrails.
Central guardrails, exactly. These are decided collaboratively, perhaps by a council with representatives from domains and the platform team. But within those global standards, the individual domains have the autonomy to make decisions about their own data products, how they model them, how they build their pipelines.
So global standards, local autonomy. Like a federal system of government almost.
That's precisely the analogy Jean-Marc Degani, who originated the concept, uses. It's federation, balancing central needs with local control to maintain order while enabling agility.
This really does sound like a very different way to organize things. What kind of infrastructure does it actually require, and what are the big engineering challenges?
Well, the infrastructure needs to be inherently distributed. Each domain might choose the best storage for its needs. Maybe one uses a data lake, another a traditional database, maybe another uses NoSQL. The platform needs to support this variety.
Well,
You absolutely need those self-serve pipeline tools, monitoring capabilities. A central federated data catalog is even more critical here for discovering all these distributed data products. And that federated governance layer needs real teeth. Things like data contracts, specifying terms between producers and consumers, clear security policies enforced by the platform, agreed upon standards for things like data formats to ensure interoperability.
interoperability seems like a huge challenge here, making sure marketing data can actually be joined with sales data if they live in different systems.
It's a major consideration, yes. Defining those standards and ensuring adherence is crucial.
So, assuming you can navigate those challenges, what are the big benefits organizations hope to gain by adopting a data mesh? Why go through all this change?
The potential payoff is significant. The biggest drivers are usually increased agility and getting insights faster, because the teams closest to the data can move more quickly.
Right, less waiting on a central team.
Exactly. You often expect to see better data quality because of that domain expertise. The people who know the data best are responsible for it. It can scale more effectively organizationally, as you're not bottlenecked by one central team. And ultimately, it aims for much better alignment between data initiatives and specific business domain needs, supporting a really diverse range of analytics tailored to each part of the business.
It sounds powerful, but also like a massive shift, especially culturally. How do companies even begin to migrate towards something like this?
It's definitely not a flip the switch kind of thing. It's a journey. The sources suggest a phased approach makes sense. You'd likely start by identifying maybe one or two key business domains that are good candidates. Maybe they feel the pain of the central bottleneck most, or have strong technical skills.
Start small.
Start small, form those cross-functional domain teams, then begin thinking about their existing key data assets as the first data products. Incrementally build out pieces of that self-serve platform. Implement the federated governance model gradually. It's as much about organizational change management, mindset shifts, and fostering a data as a product culture as it is about the technology.
And with any big shift, there must be pitfalls. What are the main challenges or things that can go wrong with a data mesh implementation?
Oh, plenty. Organizational resistance is a big one. People are used to central control. There's undeniable initial overhead in setting up the platform and defining those first data products and governance rules. Ensuring data consistency and interoperability across all these independent domains is genuinely complex, as we discussed. You could end up with more maintenance overhead overall, just distributed differently. Skill gaps within the domain teams can be an issue. Does the marketing team have data engineers?
Good point.
And the biggest risk, perhaps, is if that federated governance isn't strong enough or adopted properly, you could just end up with data anarchy, dozens of disconnected, inconsistent data silos instead of one central one. Governance is absolutely key.
So, wow, we really traced quite a path. Warehouse, lakehouse, mesh. Looking back at the sources, there was that helpful table summarizing the key differences. Can we just quickly recap the main shifts highlighted there?
Yeah, that comparison is useful. It clearly shows the trend. Data structure handling evolves from only structured warehouse to handling all types, lakehouse, mesh.
Right.
Schema management goes from upfront definition, schema-on-write, to definition at query time, schema-on-read, and then eventually to being managed decentrally within domains in the mesh. Processing shifts from centralized ETL pipelines to more flexible ELT, and then domain-specific pipelines in the mesh. Governance moves from tight central control to being federated. Scalability and cost-effectiveness generally improve with the cloud-native approaches, and the users broaden out from just BI teams to include data scientists, ML engineers, and eventually the domain teams themselves becoming data producers and consumers. The big picture is that clear move from centralization towards distributed ownership and autonomy.
And what really drove this whole decades-long evolution? It wasn't just technology for technology's sake, was it?
Absolutely not. Several key forces were at play. The sheer explosion of big data, the famous V's volume, velocity, variety was probably the biggest initial catalyst. Warehouses just couldn't cope.
Too much, too fast, too weird.
Exactly. Then came the increasing demand for real-time analytics and faster insights. Businesses couldn't wait days for data anymore. The rise of advanced analytics, machine learning, AI, these needed access to raw, diverse data in flexible compute platforms, which lakes and lakehouses provided. There was also a growing desire for data democratization, getting data into the hands of more people across the business, which the mesh aims to achieve. And underpinning all of it, the maturation of cloud computing.
Right, the cloud made it possible.
The cloud provided the scalable, elastic, cost-effective infrastructure storage, compute, networking that made architectures like data lakes, lakehouses, and even the distributed nature of the mesh feasible.
So with all these architectures now available, warehouse, lakehouse, mesh, how does an organization, or you listening, decide which approach is actually right? It sounds incredibly dependent on the situation.
It absolutely is. There's no single best architecture. The right choice really hinges on a bunch of factors specific to your organization. Things like how big and complex is your data? What are your primary business goals for using data? What level of governance and security do you need? What's your existing tech stack and infrastructure look like? What's your budget? And crucially, what are the skills and culture of your teams?
So, for instance, if an organization mostly deals with structured data, it needs really solid traditional BI reporting, the data warehouse might still be perfectly fine, right? It's not like it's totally obsolete.
That's a really important point, yes. While we've talked about its limitations for new challenges, for organizations whose core needs align well with its strengths, highly structured data, well-defined reporting, strong central governance needs, the data warehouse can still be a very effective, mature, and well-understood solution. Simplicity has value too.
Yeah.
The key is genuinely matching the architecture to the problems you're actually trying to solve, not just chasing the latest trend.
Well, this has been a really fantastic journey through the twists and turns of data management evolution. Super insightful. So what's the big takeaway for our listener from all this?
I think the core theme to hold on to is that progression. We've moved from these very structured, very centralized systems toward increasingly flexible, adaptable, and often distributed approaches.
Right.
And that whole evolution was driven by very real needs, dealing with more diverse data, moving faster, and empowering more people within the organization.
And for you listening, hopefully understanding these different architectural shifts gives you a valuable framework, a way to make sense of the modern data landscape, to understand the buzzwords, and maybe evaluate the capabilities and trade-offs of different strategies you might encounter.
It provides context for the tools and platforms you hear about.
Exactly. So here's a final thought to maybe noodle on after this. As data gets woven ever more tightly into, well, everything businesses do, how do you think that balance the tension really between centralized control and decentralized empowerment will continue to shift in your world? And maybe what role could you play in shaping that future?